Howdy folks, Mr. Reed here, and welcome to One More Question. So what I'm going to be taking a look at right now is the idea that some people really prefer to trim down on the amount of, not fluff, but the amount of notation required to actually do a polynomial division by a linear divisor. So I'm going to show you another method known as synthetic division that cuts down on a lot of the stuff we need to write down. But it ends up being a bit on the limited side in terms of its scope. So I personally don't prefer this method, but it is one that definitely, if what you need to be doing is dividing some polynomial of higher order by a linear divisor, and you just need to chunk them out and get some answers quickly, synthetic division is a great way to go about doing it. So if you want to see that done, you're in the right place. So let's get to it. Okay, so as I said, I'm going to do synthetic division. I actually put over to the side a long division. It's actually the same long division that I did in my other video. And I'm going to do a synthetic division for that exact same setup. So what synthetic division does is it basically gets rid of every single bit of fluff that could be there. And fluff is definitely not the right word. But if we set up our long division every way, or every time where you have just an x for the part of the linear divisor, so if it's not some coefficient other than 1, then we can basically just say, oh, that part doesn't matter because it's the same thing every time. So the part that really matters is the -2. So here we go, -2. And forgive me because I'm going to be switching the notation over a fair bit, but I'm going to use this little upside down symbol. It kind of looks like a division symbol. It's probably just done in a very similar way to kind of remind us of what we're doing, but different enough so that you know it's definitely not the same in terms of what you're looking at. The process is going to be very similar though. So in each of the pieces that are in my long division, I have an x to the 4, x to the 3, x to the 2, x, and constant term. They're just in descending order, and I've placed the 0 x cubed there so that it is spaced out correctly. So what really matters is not what those things are, it's where they are and how many of them there are, which is the coefficient. So it's the 3 that's important, the 0 that's important, the 4 that's important, the -1, and the 2 there for the constant term. So what I've really trimmed this down to is the parts of this that are quote unquote important for being able to actually solve the answer. As I said, I'm not really partial to this particular method because it strips away all of the underlying understanding as well. It just kind of boils it down to a process, which is okay, but not my favorite. Okay, so what we're going to do is we're always going to figure out that this number up here is because of the nature of how this goes. If we're always multiplying by x, that coefficient is just automatically the same as whatever number you start with here. So this thing just by default, I guess you could say, just moves down into an answer position. Now, every line of what's going on here is always subtract, 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 subtract. So I'm going to, other than this one place where I skip, I'm going to subtract whatever I put into these positions. So it's going to go like this. Sorry, my 3 kind of got a little bit mangled there. But so the 3 comes down, and I'm going to subtract stuff that I bring down onto this line from the thing that comes before. So probably should switch to a different color here for a moment. So after I get this 3, what ends up happening is this 3 that's a part of my answer multiplies this -2. That -2 is the same -2 that we have here. And it gets placed in this position where we subtract it from this number, which is this 0 right here. But we multiply with the -2 and the 3, and we get our -6, and then we subtract. So what ends up happening is we have basically just condensed all that first stage stuff into bring it down, because it's always going to be the same, multiply by this -2, that's the constant part of what's going on there. It gives us this -6 up here, which we'll then subtract from the 0 and get our 6. So that is the next part. Now, because of the way that the linear stuff works, this 6 is the same as what's going on here, which is then we're going to choose for this x to go in exactly that number of times, which means that we're going to get rid of that next term, but then there's going to be some leftovers that are made up of this -2. Well, I'll probably switch colors again. This -2 up here times this 6, which gives us -12. So I'm going to take that -12 and I'm going to place it right here. And in what's going on in our synthetic, it's made up of this times this. So -2 times +6 gives us -12. Then we're going to subtract again. We get 4 subtracted -12 gives us 16. Excellent. Well, we'll note if we look up above that that's the same 16 that's going on right here in the long division. And again, we are going to choose for the linear just x to go into that 16. So we pick a 16 to go up into our quotient, which is all lining up exactly the same way. So we're getting that 16, it's going in an even number of times, and then we're going to get 16 times the -2, which is this -2, and this 16, which gives us -32 here. Subtracting the -32 gives us 31. If you look up above, you can see where the 31 is. -2 times 31 gives us -62. Subtracting that -62 from the 2 that comes above it is 64. So our answer in the end is, if I copy it back down so you can see it, is 3, 6, 16, 31, 64. So this is code, but it is the code that tells us the right answer, because these are all place values that go along with what it is that we're kind of covering in terms of the order of x. So the last one, if we start with the right, because it's probably easier to think about it that way. So right is actually this way for you probably. So if we start with the right, we would have 64, and that's actually the remainder. So that is a 64 remainder, or 64 over the divisor, which is x minus 2. And then this is going to be our constant term, 31, linear term, 16, squared term, 6, and cubic term, 3, which is exactly the same thing that we have in the long division. So what I'm going to do is I'm just going to write that down and say that it is 3x cubed plus 6x squared plus 16x plus 31 plus 64 over x minus 2. Perfect. All right, so we get the exact same answer that we did last time using the long division by using this idea of synthetic division. So again, the setup for it is that we're going to take the constant part of the linear divisor and just plunk it down out front. After you've done that, you're going to draw an upside down, for no better way to describe that, long division symbol. And inside of it, we're going to place only the coefficients of the different terms of your polynomial. So in this case, I had 3, 0, 4, -1, 2. Remember to put in the zeros. It's really hard to catch that there's a problem in synthetic. If you don't put the 0 in, it's pretty much impossible to see that you made a mistake. In long division, that's not true, because you're going to be subtracting, for instance, like x cubes from x squareds, and that's not going to look right from a column subtraction point of view. But once you've done that, you bring the first number down, then you just multiply, subtract, multiply, subtract, multiply, subtract, multiply, subtract. And I can't remember how many times I said it, so in this one it might be one more, multiply, subtract, it might not be. But you basically just go multiply the number that's up above with your thing that's on the bottom, and it makes the new middle part. Subtract top from middle, makes the new bottom, multiply with the number out front, and it makes your new middle. Subtract middle from top, makes another one, multiply with the number out front, and you keep doing that till you get to the end. Again, I'm not necessarily the biggest supporter of the idea of synthetic division, but it's hard to make an argument that something that fits into a space like this isn't at least a little bit convenient compared to the long division counterpart. So hopefully you found that one helpful. If you did, like, subscribe, and as always, take care, folks.